here is the 4 first lines of my presentations in the case that I could not get my personal microphone in operation, but it seems to be operating. I must say that I have an advantage of being in a home ring, because this is just the place where I give the lectures for the basic course, and when I close my eyes I can really easily recall the challenge of heavy teaching load. That was the only joke in my talk. I will consider 6 examples, and they are fairly simple examples. Actually, students can do just the same things. They are homework exercises. They are edit fields, and edit field in SURVO has really very specific meaning, and this is just what I'm trying to. That impression I want to make you familiar with. I'm also saving the whole story as a SURVO file, so that this whole presentation will stay forever, unless somebody uses the same name in saving something. So I load one edit field which I have once made, and its name is Elo, and it looks like that. Let us have a simple look what here is. Here is a data matrix with 4 variables: x, y, and z. And I activate some lines in this edit field, and we may just try to see what this edit field is about. First I activate this line. Let's have a look what it did. We got 0s and 1s into the first column. The leftover here, the 3 columns here, they are some leftovers from previous activities and not of interest this time. Then I activate the line 17, and this gives random numbers as the values of x. And then I activate the all following lines by specific buttons, and this is the result at that moment, and then the program also does something else. It does extremely routine-wise things all the time. I mean that the copying, it was doing copying when it went down. If you paid attention, it went down to another data matrix where it copied something. But that's not, don't pay attention to the details. Then I activate this, and let's see what happens. Something happens, but don't try to follow what is happening. So, the famous card players, where are you? I recognize at least one with international reputation. I don't mention the name. Then I activate this one more time. You see that something is going on all the time. And one more time. There were 4 rounds, and if we now take a plot about the fourth one, we can recognize that this is old traditional card shuffling. But what is the message of this example is that also such things can be done within this system. Only that is just the main message of this example. I find it somewhat amazing that it is possible to do it in any statistical computing system. Now here this is a sucro which activates, which makes this plot, the first four plots automatically. Shuffle number 2, 3, and 4. So we divide the deck into 2 pieces and then we put the cards together and see how they go. And we can also have a scattered plot matrix of these first 4 shuffles. So that was the first example. It takes some time to recognize how this edit field should be done, and it is certainly possible to do by any programming language, but this is not a real programming language in at least in ordinary sense. Then I want another edit field. It's called unscope, and this is very simple edit field. Here we have 4 XY pairs. Very nice data, since the regression output of each pair is precisely the same. But if I plot these data, they are excessively different. But all numerical things are absolutely similar. In the name of calculation precisement. There is something which is of not that big interest. Here I have the data sets, the pairs, and the corresponding residuals. And I just want to show that how the residual can be calculated very easily. I activate this line number 90, and then the value of residual comes there immediately. Jump. There it is. And here are the regression standard. Here is the regression standard output from each 4 XY pair. And this, we can take a look at this stage. Here are columns for Y hat, the predicted value of Y, and column for residual. And if I wish to calculate it, I can have a specification on line 181 where Y hat must have P within parentheses after that, and it means that the predicted values will be calculated into that column, and it will happen now. There it is, there is Y hat. Here is defined the second degree polynomial. If I want to estimate what are the parameters, I just activate the estimate statement, and there are the estimated values of the parameters. And here is the curve, and if the ordinary regression line is drawn to the same figure, it gives this result. And this was the second example. The next example would be plot Efron. We have a given data set, and we are taking samples from that well-known data set. So we know the all values, but we are taking repeatedly samples from that data set, and this is the data set is down here. 15 values, just the values which are in a paper by Efron. And let us plot this data. So this is what we now have, and what we are now interested is the following thing. We take samples without replacement from these 15 observations. We calculate something from each sample. It's very popular nowadays. And this can be done surprisingly within these lines. I gave this as an exercise for the basic course some time ago. I was not able to solve this exercise until Arto Kallinen showed me how to do it. And this is the solution, very, very simple and absolutely logical. But I will not try to explain how it works, but what I find interesting and what is the message of this example is that it is possible to do such thing in this environment. And that's the key point. The rest of the story is not possible to follow when one sees it for the first time. So I activate all these lines now, and you can see that on the data matrix something is happening all the time. It is just doing this sampling without replacement. And I can go back to this G-plot and see what is the... So it is very different than the original one. Let's do the same thing with replacement, so that we are doing bootstrapping. Let's make the first. This is the original plot, and then here we have some definitions on line 90. That's very important line. Here we have defined t there, and t is a lag variable. But now it's immaterial how these things work. But and then I have sucro in this line 96 called active, and that sucro activates 3 times all the consequent lines after that. That's a handmade sucro. Now it makes it 3 times. It gives the original one. But the new one is excessively close to the original one. It is narrower, the new regression line. Now it was, the resulted regression line is a bit further. That's activate it one more time. Let's see whether we can get a regression line which would be more. Yes, it is now a bit different than the original one. So these are samples with replacement. And it is done here 200 times. It takes some time, so I only plot the result. And remember that the original correlation coefficient was something like 0.7, and it never became larger if it was done without replacement. So it is a very rare value of correlation coefficient in that sense. And what about the if replacement is being done, then this is the distribution of resulted values of correlation coefficient. So much about Efron. And may note the Hubere. This is a data set, very simple data set with 6 observations. And if I plot X and Y, I get this plot, and you can see that it is a very specific data set as regards observation number 6, which is influential. So, and if I have here in data matrix some columns ready, prepared for line 19. If I activate the line 19, I will get these regression diagnostics there immediately. And Professor Cook's distance is the one column here, and the observation number 6 has really huge value. So it's
I don't know what Professor Cook will say about his distance here, because normally it's squared.
Yes.
But I have tried to take a sine square root, because the standard formula for computing, or the best formula for computing, gives the possibility to also to attach a sign to this. And I am preferring to use this measure in this form, although it's rather difficult to interpret in this original sense, because then it behaves when we compute, for instance, correlations between those various statistics related to regression diagnostics, then this behaves in a similar way than the student size, the residuals and hat matrix and so on. So
we may at reception ask Professor Cook how he prefers his distance to be served.
Yeah, he may be very angry.
Can your distance be negative? What I do have here, I will show how to manipulate the plot if we want to delete one observation. I define this U in this way that I activate this line 37. U has now all values ones except the first one, and this is the result of activating this line 37. And now if I go one line below and I take this percent symbol off and I go to the next line, then this int means that only those observations will be taken into account who satisfy this condition that U is equal to 1. So observation number 1 is away, and this is the resulting regression line. And I could do this by hand repeatedly, but it is very easy to make a SURVO which makes just these things. And it is done here. It is this for line 45, and if I activate it, then I will get all plots where one observation is deleted. Now it's observation number 2 is deleted. And this is very helpful. I would say that it's not always that easy to see all plots such that one observation is deleted. It's a straightforward work, and then here is the last, and the regression line really changed. And this is just the thing what Cook's distance square root of square really measures. The bigger Cook's distance is, the bigger the change in the regression line is. Okay, let's see a couple of more things before Mustonen will kick me out here.
I think he's not coming before 6 because this was delayed by a quarter.
Yes.
We started an hour and 5 minutes ago.
Yes.
And we should have 1.5 hours so that
Yes.
there's no hurry.
Let's see what happens if I do that. If you pay attention, I typed there gear 1.6 and then I activated that line, and this was the result. I got some text there, and most of this text is normal text which could appear in any textbook of statistics. But this differs on the other hand very much, because I can activate some parts of this it offered me that if I'm happy with the current situation, I could activate this, but I will not. I'm not happy. I will change the values of X variable. I put here 1 and here 2 and here 2 also, and 3. So I have written here a linear model. I have given the X values. I have defined what is the true regression coefficient and the slope and the location. Beta 1, beta 0, and the sigma squared. It is 1. But I don't want to change them. Now I start to generate observations from this model, and this is the next step. I have this SURVO has written here down all formulas needed if one wants to generate observations from a linear model. Epsilon is defined in a usual way. It's standard deviation sigma times white noise. Y1 is as it is in linear model. YH is Y hat. E1, E2, they are residuals. So this is just like in any textbook. And still that everything is okay. I activated that SURVO, and what is here? Here are some standard regression formulas. Just ordinary formulas, but they are available. They really have some meaning. They are all only formulas. Nothing has been calculated so far. Let's see what happens if I activate this. It created a starting point for a data matrix with 6 y values. And there will be now 100 generations from this linear model where we have 6 observations in each generation. And if I activate line 43, all these variables will be immediately calculated. If immediately means 30 seconds. It is calculating regression coefficients, correlation coefficient, t-value, mean square error from each 100 sample, 100 times. There it is. And if I activate this sucro, you will see what it then does. Here are the t-values, 100 t-values from these generations, and the 5%, the level of 5%, 95% critical value has been marked, and only 5 values of these t-values should be outside these limits, and there are, seems to be 2 outside the limit. One is on the borderline. So it works very well according to the theory as it should. I may now change the real value of beta 1. Let's put there that it is 0.2. And now it is testing whether the test statistic is testing whether beta 1 is 0, and now we know that it is not 0. So the hypothesis should be rejected 100 times if the test would be very good. Let's see what happens. So everything else can remain as it is. I only activate this line one more time, and new values will be generated according to this new model where beta 1 is different from 0. Now there are more values outside this interval, but not that many still. So we easily accept the wrong hypothesis. This may hopefully help students to understand what is the meaning of t-test in regression. Maybe I use 1 minute very quickly for
let's spare some minutes for discussion, and
yes,
I have some concluded
remarks. Yes. This is another way of generating observation from linear model. It's very different, but I have defined the model on line 5. I'm happy with everything. I activate this. Data matrix is coming, and this is the first generation from that model. And if I wish to do more generations, I activate this again, and you can see that on the data matrix something is happening all the time. There is life. But you can see that now I don't have here 100 lines. I don't make 100 generations. But one can very easily see that in data matrix something is really happening if I generate new observations. Y is a sum of a linear combination. It's beta 0 plus beta 1 x, and the values of x are in this data matrix. Try to finish this SURVO. I think I did it now. Let's see if I yes, here is the code of everything what I did. And now if I activate this SURVO, I can repeat everything what I was doing for the last 35 minutes. So that's the end of the story this time.
But you have not the courage to try.
but yes, I have not. But it's now a SURVO which can be easy for anybody can see just the same thing.
Yeah, thank you very much. You see the idea that the SURVOs are first usually made by an example, just using the system, but letting the system to save all the keystrokes. And then it can be loaded back to the edit field and edited, and then we can also add the prompts for the user and have conditional statements. The SURVO can read various results, store them in the specific internal memory, and on the basis of the contents of this memory, it can make decisions in the way. So we can generate both teaching programs and a sort of expert applications for various tasks. Many of the advanced SURVO users are using now this technique to improve the quality of their work. Are there some? I have one remark for the Finnish people, or people who are able to understand Finnish, because I have one handout for them about some teaching programs related to SURVO. But are there some questions or comments on this, what we have done with Simo?
Yes.
Do you have any experience when you talk about how good learning experts are distributed in teaching? For example, if we have to place you for do you have any experience?
Was the question so that how well can a SURVO replace me?
Yes. In a way.
I don't have experience, but to some extent it could perhaps, but I think it would really maybe I underestimate myself. But I think that to make a really it's very difficult to say because I don't have experience. I think that this is one of those things which really require experience until one is able to say how things will go. On the other hand, to do something entirely based on a computer, everybody knows that it can really be killingly boring. It can really be that. But on the other hand, it can be really saw that the enthusiasm is can be observed, and we have been using this for 2 years, and we have no plans to give up. But I think that the human being is badly needed. But sucrose are I find them excessively good.
By sucrose we can teach our working habits, how we want to solve problems. And now I have spent the last year for the most part in making sucrose in Finnish, and they are intended to be used in secondary schools and high schools, in teaching this technique we are using in SURVO, and both for teaching mathematics, statistics, data analysis, probability, and so on. And as I said, I have, for the Finnish audience, I have a handout telling about the current situation of the school version. There is a cut-off version of SURVO available within 1 month. It contains about 50% of the current functions of the whole SURVO. And there are limitations for the dimensions of the data, so that, for instance, the maximum size, number of variables is about 15 and cases 500. In the true SURVO, we have no such limitations. In practice, we could have, for instance, up to 5,000 variables and no limits except the limits on the disk for the number of observations. But in the school version, we don't need high capacity. We need good qualitative means for making teaching programs and using them. And therefore, I have tried to create a rather long series of tutorials by this sucro technique. And here is a list of 5 pages about 150 different sucrose now available for teaching. Anybody who likes to have this can take one copy. Yes. Any more questions or comments? Yes, it's time to conclude this session. Thank you for your interest.